Imagine you are trapped inside a steel tube, 300 feet beneath the freezing surface of the North Atlantic. Around you, the air is thick, reeking of diesel fuel, battery acid, and the unwashed sweat of 50 terrified men. Above you, Allied destroyers are hunting, dropping depth charges that shake the ocean itself. But the real danger isn't coming from the sky. It isn't a torpedo. It isn't a naval mine. The real danger is already inside the boat, and it is entirely invisible. A Type VIIC U-boat was a marvel of 1940s engineering. It weighed nearly 800 tons, cost millions of Reichsmarks, and required tens of thousands of man-hours to construct. It was the apex predator of the ocean, the grey wolf. But as the submarine dives deeper to escape the warships above, the immense, crushing weight of the ocean, over 130 pounds per square inch, begins to squeeze the hull. The steel groans. It actually shrinks. And deep within the maze of the engine's cooling system, a microscopic flaw begins to wake up. It is a gap smaller than a grain of sand. A manufacturing defect so minuscule it would cost less than a single pfennig to correct. It is, quite literally, the 1 cent mistake. But at this depth, water doesn't just leak. It slices. Within minutes, this 1 cent mistake will bypass every defensive system the submarine has, tear through its vital machinery, and send 80 million Reichsmarks of military hardware and its entire crew to the bottom of the ocean. Today we are diving deep into the secret, high-stakes world of industrial sabotage. We're going to uncover how a shadow army of factory workers used the unbreakable laws of physics and chemistry to turn Germany's most terrifying weapon into a self-executing steel coffin. This isn't a story about bombs or bullets, it's a story about the ultimate Trojan horse. To understand how you sink a submarine from the inside out without anyone noticing, you first need to understand the brutal engineering challenges of underwater warfare. When a U-boat is on the surface, it runs on massive, roaring diesel engines. These engines generate a colossal amount of heat. To keep from melting down, the submarine pumps freezing Atlantic seawater from outside the hull, circulates it around the engines to cool them, and pumps it back out. This means that running right through the heart of the submarine is a pipeline directly connected to the infinite, crushing pressure of the ocean outside. Keeping that water inside the pipes is a matter of life and death. In 1943, the German war machine was running out of skilled labor. To keep the shipyards operating, the Nazi regime utilized thousands of forced laborers from occupied territories: France, Belgium, the Netherlands. These men and women knew that overt sabotage, like smashing a machine or planting an explosive, was a guaranteed death sentence. The Gestapo patrolled the factory floors. Every part was inspected. Every worker was watched. So, the resistance had to get creative. They had to sabotage the parts in a way that would pass rigorous factory inspections on dry land, but fail catastrophically when it mattered most. They engaged in what engineers call macro-detail sabotage. Imagine a forced laborer tasked with preparing the massive metal flanges for the U-boat's seawater cooling lines. These flanges must perfectly mate against a rubber gasket to create a watertight seal. With a few precise hidden strokes of a coarse file, the worker introduces a microscopic burr, a jagged, uneven ridge of metal along the seating surface. It's completely invisible to the naked eye. When the German inspector walks by with his flashlight and gauges, the piece looks flawless. But there's an even more insidious method, the chemistry of galvanic corrosion. When two dissimilar metals, like high-carbon steel and a copper alloy, are placed in direct contact with each other in the presence of an electrolyte, like salt water, they create a primitive, invisible battery. An electrical current begins to flow between the two metals at an atomic level. As this current flows, the anodic metal, in this case the vital steel bolts holding the pipe together, begins to sacrifice its own electrons. It literally dissolves into the water. The saboteurs knew this. By simply swapping out a single high-grade stainless steel washer for a visually identical, cheaply coated copper alloy washer deep inside a valve assembly, they armed a chemical time bomb. When the U-boat is launched in the harbor at Kiel, the pressure is low. The microscopic burrs and the mismatched metals hold tight. The submarine passes its sea trials with flying colors. The crew celebrates. The captain is confident. The factory inspector signs off. But the saboteur knows something the Gestapo doesn't. They know the laws of physics are absolute. The submarine is completely doomed and it hasn't even seen combat yet. This is what structural engineers call a silent failure. The U-boat leaves port and begins its patrol. For the first few weeks, everything operates precisely as intended. But as the submarine dives to evade an Allied patrol, the environment changes radically. At a depth of 150 meters, the hydrostatic pressure is immense. The ocean is actively trying to crush the submarine like an empty soda can. The thick steel hull compresses. It bends. As the hull flexes, the internal pipework is subjected to terrifying mechanical stress. Remember that microscopic burr? That 1 cent mistake filed into the metal? Under the immense flexing of the hull, the gasket sitting against that burr is squeezed and twisted. The tiny gap opens up, just a fraction of a millimeter. Suddenly, the ocean finds its way in. But at this depth, a leak isn't a drip. Because of the extreme pressure, water forced through a microscopic pinhole accelerates to devastating speeds. It becomes a high-pressure water jet. The crew hears a sharp, violent crack. They scramble with flashlights, looking for the source. But the pinhole leak is hidden behind a wall of roaring diesel machinery. This water jet is so powerful that it acts like a laser. It cuts through electrical insulation. It slices through rubber hoses. And worse, it begins to rapidly widen the microscopic flaw in the steel through sheer kinetic erosion. What starts as a pinhole becomes a hairline fracture. What starts as a fracture becomes a rupture. Meanwhile, in another part of the sub, that mismatched washer has been quietly dissolving for 3 weeks. The bolts have lost 60% of their structural integrity to galvanic corrosion. They are brittle, hollowed out by chemistry. The moment the submarine is shaken by a distant depth charge, the vibration travels through the hull. The bolts snap. The valve blows out completely. Hundreds of gallons of freezing Atlantic seawater flood the compartment every minute. The water hits the massive electric batteries stored beneath the floorboards. When seawater mixes with battery acid, it instantly generates chlorine gas, a deadly, choking vapor. The pumps are overwhelmed. The added weight of the water in the stern pulls the submarine backward. The trim is lost. The submarine begins a terrifying, uncontrollable slide backward into the abyss, plunging past its crushed depth. The crew fights desperately, but there is nothing to fix. You cannot patch a hole that is under thousands of pounds of pressure. The 1 cent mistake has executed its payload. The U-boat implodes, vanishing from the surface of the Earth in a fraction of a second. When a U-boat simply disappeared in the Atlantic, the German High Command usually blamed Allied destroyers or sea mines. It took years for them to realize that their own production lines were infected. The people who carried out these acts were not highly trained commandos. They were not James Bond. They were the invisible front. Consider the sheer, terrifying courage required to be a saboteur in a Nazi shipyard. You are a captive laborer. You work 14-hour shifts under the watchful eyes of armed guards. You know that if a machine breaks down on your watch, you will be interrogated. If they find a vial of acid or a mismatched part in your pocket, you will be executed on the spot, and your family back home will likely suffer the same fate. Every act of sabotage required ice-cold psychological control. Records from 1943 and 1944 indicate an inexplicable spike in mechanical failures across the Kriegsmarine. Some historians estimate that up to 15% of all U-boat technical malfunctions during this period were the result of deliberate, silent sabotage. A worker might purposefully strip the threading on a single screw inside a gyro compass, ensuring the submarine would eventually navigate off course. Another might take a rag soaked in gritty metal shavings and wipe it perfectly clean, leaving just enough microscopic dust inside an engine cylinder to slowly score the pistons and cause a catastrophic engine seizure after exactly 300 hours of operation. They never got to see the results of their work. They never heard the explosion. They just had to trust that the laws of physics would do the rest. They traded their daily safety for a tiny flaw in a piece of steel. But the impact of these silent heroes was staggering. It wasn't just the physical loss of the submarines that crippled the German Navy, it was the psychological attrition. When U-boats begin failing for no reason, when engines seize in the dead of night, when pipes burst on routine dives, paranoia sets in. The crew stops trusting their equipment. The captains become hesitant to push their boats to the limit. The hunters realize that the very ship they are sailing in is a traitor. When we look back at the history of global conflicts, it's easy to get distracted by the scale of it all. We write books about the grand strategies of generals. We marvel at the massive battleships, the sweeping tank maneuvers, and the cracking of the Enigma code. We are conditioned to believe that huge victories require huge weapons. But the physical universe doesn't care about grand strategies. Engineering is entirely unforgiving. A machine is only as strong as the intent of the hands that built it. The fall of the U-boat menace was undoubtedly hastened by brilliant code breakers and brave sailors, but it was also destroyed from the inside out by the man with a file hidden in his boot, by the woman who intentionally miscalibrated a pressure gauge. They proved that you don't need a 1,000-pound bomb to destroy an 800-ton leviathan. You just need a deep understanding of pressure, a sliver of bravery, and a microscopic flaw. Because history tells us that wars are won in the factories, but they are lost in the details.